Assalamualaikum and hi everyone. My name is Nur Fatim Farana binti Zaid. So, in this video, our group will be presented a topic in a chapter 3 which is Application of Differentiation. We will apply the application of differentiation in geometry. So, let's get started. Let me introduce a little bit about this topic. Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions. For example, the volume of materials, area, and profit. Derivatives are made in many engineering and science problems, especially when we modeling the behavior of moving objects. So, in this topic, we will come up with some example using question to discuss about the application of differentiation in geometry. Before that, why we choose the topic? It was because we will apply the maximum and minimum problem since the topic is suitable for geometry functions. For your information, the Egyptian, the Romans, the Greek used the geometry in the word of architectural construction.
Hi, my name is Nur Natasha binti Sadri. Question 1. An ice cream cone is made from a circular shaped pastry using flour and sugar ingredients which have a radius, and given the side is 10 cm by cutting out a sector and make a conical shape. What is the maximum volume of the ice cream cone to fill up an ice cream?
In this slide, we have to find the h value. So first, the formula volume cone is 1 over 3 pi r squared h. So this is the first step we must to know. So in this question, we are given the side of the cone is 10 cm, the radius is r cm, and the height is h cm. So the second step is, we have to do the hypotenuse theorem, that is r squared equal to 10 squared minus h squared. So third step is, we have to substitute r squared into the first step. So the volume is equal to 1 over 3 pi times 10 squared minus h squared times h. So now we get 1 over 3 pi h times 100 minus h squared. So next step is, we have to expand this 1 by 1. So 1 over 3 pi h times with 100 is 1 over 300 pi h, and 1 over 3 pi h times with negative h squared is negative 1 over 3 pi h cubed. So the volume is equal to 100 over 3 pi h minus 1 over 3 pi h cubed. So next step is, we have to differentiate the volume. So V prime is equal to 100 over 3 pi minus pi h squared. So let V prime equal to 0. So 0 is equal to 100 over 3 pi minus pi h squared. So bring negative pi h squared to the other side. So pi h squared equal to 100 over 3 pi. So now we can cut pi. So h squared equal to 100 over 3. So move square to the other side. So h is equal to square root 100 over 3 is 10 over square root 3. So this is the answer of h value. To find the maximum volume, first step is, we have to know the formula of volume cone. So the volume is equal to 1 over 3 pi r squared h. Second step is, we have to substitute r squared and h value into the volume. So the volume is equal to 1 over 3 pi times 10 squared minus h squared times 10 over square root 3. Third step is, we have to solve 10 squared minus h squared. So 10 squared is 100, negative h squared is negative 100 over 3. So next step is, we have to times 1 over 3 pi with 10 over square root 3. So we get 10 pi over 3 square root 3. And then 100 minus 100 over 3 is 200 over 3. So last step is 10 pi over 3 square root 3 times 200 over 3 is 2000 pi over 9 square root 3 cm cube.
The process of finding maximum or minimum values is called optimization. So in this question, we are finding the maximum volume of an ice cream cone to make sure that its size is compliant with other ice cream cone or more. These are very important in the world of industry.
Question 2. A rectangular fish pond with an area of 60 meters square is surrounded by a flower border with 3 meter wide on two sides and 2 meter wide on the other two sides as shown in figure above. Let x and y be the length and width of the fish pond respectively.
For this question 2, we have 3 questions to ask. First, show that the combined area, fish pond and the flower border is area equal to 4x plus 360 over x plus 84. For B, what dimensions of the fish pond will minimize the combined area? For C, what is the minimum combined area?
Show that the combined area of fish pond and the flower border is area equal to 4x plus 360 over x plus 84. We know that the formula area rectangle is width times length. So the width of flower border is x plus 6 because here is 3 meter and here is 3 meter. So 3 plus 3 is 6. And the length of flower border is y plus 4 because here is 2 meter and here is 2 meter. So the area of fish pond is already given, that is 60 meters square. So first we have to find the area. So the area is equal to x plus 6 times y plus 4. Before that we have to find the area of fish pond. That is x times y equal to 60. So y equal to 60 over x. And then we have to substitute y into the area. So second step, x plus 6 times 60 over x plus 4. So next step is we have to time this one by one. So x times with 60 over x is 60, x times 4 is 4x, 6 times 60 over x is 360 over x, 6 times 4 is 24. So the last step is we have to add 60 and 24 together. So the area is equal to 4x plus 360 over x plus 84. So this is showed same as the question. What dimensions of the fish pond will minimize the combined area? So first step, the area is equal to 4x plus 360 over x plus 84. So x bring up, it will be the 360 x to the power of negative 1. So third step, we have to differentiate the area. So dA over dx equal to 4 minus 360 x to the power of negative 2. So next step is let dA over dx equal to 0. So 0 is equal to 4 minus 360 over x squared. And then we have to time x squared both sides. So now we get 0 equal to 4x squared minus 360. Bring 4x squared to the left side. So negative 4x squared equal to negative 360. So now we have to move negative 4 to the other side. So x squared equal to negative 360 divided by negative 4 is 90. So next step is we have to move square to the other side. So x equal to square root 90 is 9.4868 meter. So next step is the area of fish pond is x times y equal to 60. Based on step 11, we have to substitute x into the area. So 9.4868 times y equal to 60. So y equal to 60 divided by 9.4868 is 6.3246 meter. What is the minimum combined area? So the area is equal to 4x plus 360 over x plus 84. So first step, in previous slide we have already find the x value. So x equal to 9.4868 meter. To find the minimum area, second step we have to substitute x into the area. So the minimum area is equal to 4 times 9.4868 plus 360 divided by 9.4868 plus 84. So the answer is 159.8947 meter square.
For the question 2, the process of finding the minimum combined area of fish pond and flower border is to estimate the widest needed to build a fish pond and having a flower border. This is to ensure that the owner of the house desires achieve. These are very important in the world of construction.
In a nutshell, the maximum and minimum concept are useful in our daily life and even could give benefits to people. For the first question that we have made earlier, the concepts are being applied to help producers to find the largest possible volume of ice cream cone so that a large pile of ice cream could fit into the cone. And at the same time, it could give maximum satisfaction to the customers as they can enjoy a lot of ice cream. So for the next question, the concepts are being applied to guide people to find the dimension of fish pond so that the combination area of the fish pond and the flower border will have a least total area. Usually, these concepts are useful in construction sector, especially when they are planning to build something in a limited space area. For example, they are planning to build a small hut in a small garden. So by applying this concept, they could find the possible largest or smallest size of the hut that can be built in that small garden.